Hello and welcome to another review with Mr. Cruze. This time we have trigonometry going on. You guys have a take-home quiz this weekend, and I thought I would give you a little just extra help with one of these word problems. Hopefully you can see what it takes to set one of these up and what it takes to answer some of these questions. So hopefully this helps. At any time, of course, you can always tweet me if you have questions, you can email me, or you can comment to this video, whatever it takes. This video should be nice though, because you can rewind it, watch it over again, and make sure that you know what you're doing. Of course, I'm not actually doing a question that's on the quiz, but hopefully they're very similar. So this one's number 5 from page 100 in your textbook. A weight attached to the end of a long spring is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time, of course. You start a stopwatch. When the stopwatch reads 0.3 seconds, the weight first reaches a high point 60 centimeters above the floor. The next low point, 40 centimeters above the floor, occurs at 1.8 seconds. So first they want us to sketch a graph of this sinusoid. Okay, so we can do this. Just sketching a graph. Notice they say when it reaches 0.3 seconds. So our time t is our x-axis, and our height h is how far above the floor we are. Okay, obviously 0 is the bottom where it hits the floor, but we don't need that. Let's see, at 0.3 seconds, so we'll just say it's 0.3, the weight first reaches a high point of 60 centimeters. So there's a point there. The next low point is at 40 centimeters. So we have a low point here at 40 centimeters, and that occurs at 1.8 seconds. So we'll put 1.8 somewhere down here. And so you can imagine what's happening with our graph. Okay. Obviously starts plummeting pretty fast and then slows down as it gets to 40. Okay. Looks like half of a cosine graph, right? You could almost imagine the other half being over here and being at some other point. Okay. Just alternating between 60 centimeters and 40 centimeters. Not a big deal. Alright, so there's our sketch of our graph. Now, of course, they want us to write an equation, which we can do. That's pretty easy. We basically need 4 things. We need our a value, our b value, our c value, and our d value. Okay? D should be pretty easy to get. Obviously, we didn't start at 0 seconds. Technically, we did start the stopwatch at 0 seconds, but we'll get to that later. We want to know where's the high point. Because remember, if we can use cosine, a lot of these problems are going to be much easier, and cosine starts at a high point, so we need to figure out where that high point is. So D is 0.3. We'll just have to remember that's 0.3 and not 3 later. Alright, what else do we have? Well, we know that our high point is 60 and our low point is 40. So that means our axis, our vertical shift, is somewhere halfway between them, right? There's an axis going on there. Well, what's halfway between 60 and 40? Well, there's 2 ways you can get that. You can take 60 plus 40, divide by 2, and it'll be 50. Or you could know 50 is exactly between those two. Sometimes it's not that easy, though. So that's our c value. We've had to shift our entire graph up 50. Well, what's our amplitude then? Well, amplitude is just the distance from the new axis to the high point or the low point, which is just 10. Okay? The last thing we need to get is our b value, and I think that's where a lot of us are having difficulties. Okay, we need to figure out how long is our period. Okay, how long is this full stretch? We know half of the stretch. It's from 0.3 to 1.8, which is 1.5 seconds, right? 1.8 minus 0.3 would be 1.5. So how long is the full cycle, the full period? Well, it's 1.5 plus 1.5, which is 3. 3 seconds for a cycle, or 3 seconds in a period. Okay? But does that mean that's our b value? No. You have to take 2 pi divided by your period to get b. 2 pi divided by the period. So in this case, 2 pi divided by 3, which is just 2 pi over 3. And now we can write our equation. I'm going to use h instead of y. Technically it's height, so really doesn't matter. You could use Batman symbol if you wanted to. Y equals c. Obviously this is positive cosine because we're starting at a high point, not a low point. So plus a cosine, so 10 cosine, b times t minus 0.3. And again, it's minus 0.3 because we started at positive 0.3. Take the opposite of what you see. So there's your equation. We could literally find, you could give me any point in time, we could figure out what the height of the spring is. You could also give me any height, and I could tell you at what times those heights are. And that's what we're going to be doing next. Alright. Predict the distance from the floor when the stopwatch reads 17.2 seconds. 17.2 seconds here. Okay. What variable in this equation would be seconds? Well, that would be t. So we're plugging in for t, 17.2 seconds. Okay, so you're going to do h equals 50 plus 10 cosine, let's see, 2 pi over 3 times 17.2 minus 0.3. You could clean this up a little bit if you'd like. For instance, 17.2 minus 0.3 would be 16.9. Okay. And you could even do a little more if you wanted to, right? But I would just stick to this. I would just go ahead and be ready to type this in. So let's see. Turn my calculator on here. As always, make sure, since these are in radians, make sure you're in radian mode. We want to be in radian mode. So I would just literally type this in. 50 plus 10 cosine. Hopefully your calculator's a little more cooperative than mine is. 10 cosine. 2 pi over 3. Notice I'm not closing my parentheses. I'm just going to put times now. 16.9. Do not close your parentheses until the very end, and then you can do it. Okay? So what's the height when the stopwatch reads 17.2 seconds? We'll cut that off to two places. So 43.31. 43.31, and I believe it was centimeters. Again, obviously, use common sense on these problems. I know the high point is 60. I know the low point's 40. It has to be between 40 and 60. It could include them, but it has to be between them. Okay? If you get some weird answer like 22.5, obviously you should know that's wrong. Okay, something is incorrect. What was the distance from the floor when we started the stopwatch? Okay? Well, when exactly did we start the stopwatch? Assuming we used the stopwatch correctly and actually started it where it was supposed to be started, we should have started at time equals 0, okay, assuming we reset it like we were supposed to. So basically they're asking us to plug in t equals 0. So h equals 50 plus 10 cosine 2 pi over 3 times 0 minus 0.3, t minus 0.3. Well, what's going to happen here? This shouldn't be too bad. 50 plus 10 cosine 2 pi over 3 times negative 0.3. Okay, so let's go to our handy-dandy TI-83 calculator. 50 plus 10 cosine 2 pi over 3. Once again, I'm not going to close off parentheses. 2 pi over 3 times negative 0.3. And let's see what happens. We get 58.09. 58.09. So where did the spring start? 58.09 centimeters. Should make sense because 0.3 seconds later it was already at 60 centimeters, right? But once again, you're talking about the height of this thing. It should be between 40 and 60. If you got some other answer, you would know you are incorrect. And last but not least, I think these are the hardest ones, the ones you guys struggle with the most, okay? Predict the first positive value of time, the first positive value, at which the weight is 59 centimeters above the floor. Well, a little logic should tell you, if it starts at 58.09 centimeters and it hits its high point 0.3 seconds later at 60 centimeters, there is a rule later that you might learn in calculus that says there has to be some point between t equals 0 and t equals 0.3 where it hits 59. So my answer should be between 0 and 0.3. Okay, but that's beyond us. For now, we want to know the height is 59 centimeters. Well, what variable corresponds to centimeters? That'd be h. They want us to know, when is h 59? So I'm going to plug in 59 equals 50 plus 10 cosine 2 pi over 3 times t minus 0.3. And we're going to find t. Start moving everything to the right. Subtract 50, so that'd be 9 equals 10 cosine 2 pi over 3 times t minus 0.3. Divide by 10, and at this point, if you don't care, I'm going to go ahead and start crossing things off. To get rid of the cosine, you're going to take the inverse cosine. That gets rid of the cosine. To get rid of the 2 pi over 3, I'm going to multiply by its reciprocal, which would be 3 over 2 pi. That gets rid of that. And last but not least, add 0.3 on to the front. And that'll just leave us with t. So, this is basically what we're dealing with. 0.3 plus 3 over 2 pi, inverse cosine of 9/10. I'm going to deal with this part right here, the inverse cosine of 9/10. Let's do that first. So I'm going to go to my calculator. Let's clear off what we already did. Second cosine of 9/10. Or if you want to do 0.9, you can do that too. That is 0.4510. I'm going to do 4 decimal places here until the end. 0.4510. Okay? When you do that, you also have to include plus or minus, because with cosine, it could be the positive one or it could be the negative one. So plus or minus 0.4510. Obviously, it varies every 2 pi, right? So 2 pi in. Alright, let's distribute this 3 over 2 pi business. Let's make this simpler, okay? 0.3 plus, we're going to distribute the 3 over 2 pi. So I'm going to go to my calculator. This is where you have to be careful, alright? 3 over 2 pi. Your calculator is only as smart as order of operations. If you just type 2 pi right now, it's going to take 3 divided by 2 times pi, and that's not what you want. We want the whole 2 pi to be on the bottom, so you have to use parentheses here. That way it knows to multiply 2 pi first, and then take 3 divided by that. So, times 0.4510. Trust me, if you don't have the parentheses there, you will get a completely different wrong answer. Alright, so we have 0.2153. So we have 0.3 plus or minus, because positive times plus or minus is that. What did I just say? 2153. 0.2153 plus 3 over 2 pi times 2 pi n. The 2 pi's will cancel, and you're left with 3n. So basically you're adding some multiple of 3. Won't be too big of a deal because we just want the first one. So we have 2 possible answers here. One where it's 0.3 plus 0.2153, and that's 0.5153 plus some multiple of 3. Obviously, subtracting 3 from that would leave it in negative territory, so basically this is going to be the first positive time that this side of the equation would give us. But what about 0.3 minus 0.2153? Let's figure out what happens there. 0.3 minus 0.2153. Something tells me that'll be a little smaller. 0.0847 plus 3n. Obviously, I would not want to add 3 or subtract 3 because adding 3 would make us bigger, subtracting 3 would take us into negative territory. So this is the first time where it happens. Which is smaller, 0.0847 or 0.5153? Well, this one's smaller, 0.0847. Let's round it to a couple places, 0.08 seconds. Alright, that's the first time that it happens, that it hits 59 centimeters above the floor. Obviously, they could then ask a follow-up question, is it going up into the air or is it coming back down? Well, if it started off at 58.09 centimeters as indicated up here, 0.08 seconds later, it's up to 59, that means it went up. Okay, so there are some questions where you have to think about those kind of things. Alright, I hope this video has helped you study for your quiz. We are going to be having an in-class 2-question quiz on Monday, so make sure you know how to do these problems, alright? Take home, you can use notes and stuff, but not on the one in class, alright? As always, I wish you good luck. If you have any questions, just let me know, and I will see you guys later.